Hi, this is Jason and this is my Sprint 3 retrospective. In this video, I like to walk through about my contributions which I made in Sprint 3. In this sprint, I took a leading role in systematically testing the web application. So this is the working web applications which we have. I'm at the monthly average view at the moment. So basically, if a user selects some particular month, particular year and a particular month, the heat map pops in the screen. So my responsibility in this sprint is to validate the heat map generated by manually generating the heat map in the backend and testing it with an application called Panoply. In this sprint, I've tested the heat map generated for the different features of the web application, which include monthly, seasonal, the climate drivers, Enzo IOD, and finally synergetical view analysis. So I did about 30 to 40 user test cases for each category, and I've compared it with the Panoply generated image and made sure the image which we are actually seeing in the screen is what the app is actually supposed to produce. Also in this sprint, I've increased the year range for 30 years compared to what I did it in sprint 2, which was just 5 years. And I've also introduced semi-automatic testing in this sprint to make things easier than the last sprint. So let's get into the code. So this is the working code which we have at the moment. So basically what this code does is, so when a user selects a particular input, so year and month range, so it goes to that particular, for monthly data case, it goes to a particular month's folder and it fetches the particular month's data. So this is the monthly data which we have. So it fetches the monthly data and shows the monthly data in the screen to the user. So in the semi-automatic testing process, what happens is, so when a user selects a particular month and a particular year, so it fetches that FFDI image and it binds it together and puts it in a folder. And it's similar for other functionalities as well. So if I go to Enzo view and if I select a phase and a particular year duration, let's say if I select from 1999 to 2006, so it goes to a particular CSV file and it selects the for El Nino, the Enzo value is supposed to be more than 0.5. So it goes to the CSV folder. It has been already categorized into different season. It goes to the particular year category and checks whatever values which is greater than 0.5 and it binds it together based on each seasonal category and it chucks it into different folders. And in the systematic testing process, I fetch the values in a separate code and I bin it together to a single FFDI file. And then using Panoply, this is the Panoply, and using this application, I plot a map for that specific heat map. And using this information, I compare the app generated heat map with the Panoply generated heat map and made sure that both of them matches together. Also, I made a report of the comparison between app generated and Panoply generated. Let's have a look at it. So this is the report which we have. So if you open this, so it basically shows the app generated heat map with the Panoply generated heat map. So basically, I just created 4 different Australian maps and bin it together. So the color code might be different. So if you look at the pattern here, it's mostly the same. It's just the FFTA color code values are different. I did the same for multiple different iterations for different features, and I made a report for some of them, but I've tested for more than about 200 to 300 test cases and I made sure the application works as it's supposed to. With the semi-automatic testing, I've also tested manually if whether the functionalities of the web application works fine, like the drop-down menu, and if all the year ranges are present in the range. Made sure all the image functionalities works fine, like if the user wants to take a picture of the snapshot, if he clicks the icon, if it works. I tested it for different iteration as well. It was working fine and user panning mode, zoom in mode for a particular thing. I tested it for different features and made sure everything aligns with the project requirement. And along with the testing process, I'm also responsible for refactoring the code base. Initially, the logic was handled by a single Python file, which included all the logic in a single file. So we separated the logic into multiple different of modules and we just modularized the whole code. So it'll be easier for further development. So if somebody was handling this project for future iterations, it could be easier for them to make a change or debug the code. And now moving on to what could have gone better. For the sprint, I've tested for 30-year range. I could have tested more, but due to some due to some time constraints, I stuck with a 30-year range. Also, if I increase the year range to more than 40 or 50, it takes a lot of time for the application to load in my system, because in my system, the random access memory is quite short. So I couldn't increase the range more than 30, but I tested for multiple 30-year ranges. So let's say now it is 1985 to 2014, but I've tested it for 75 to 95 as well, and different permutations of testing has been done, and the results has been also recorded. And to wrap this up, Sprint 3 has been really productive to me. To wrap this up, I believe Sprint 3 was really productive to me. I integrated automated testing, and I've compared different outputs, and I've tested all the possible outcomes. And it made me realize how important is automated testing, and it saved a lot of time compared to Sprint 2. And this sprint wasn't just to make sure if things work, it's to make sure that things work right. And I believe I've achieved my goal of this sprint. Thank you.